This is the third and last of a series of videos on mastering resonance. In this video, we will focus on how electron delocalization and the resulting resonance effect impacts our understanding of the hybridization of the atoms involved. We see here resonance forms of an amide structure. Hopefully you recognize the allelic lone pair. It is important to remind you that resonance involves pi electrons in p orbitals. To highlight this idea, if you take a look at the structure of the amide over here on the right, I've tried to imply that from the oxygen through to the carbon to the nitrogen, this whole region here is planar. And we have electron delocalization of pi electrons in p orbitals. So one of the ways to actually think about this in structure right here is to understand that we have p orbitals sticking perpendicular to the plane, both above and below the plane, and that the pi bond that we show between the oxygen and the carbon also exists between the carbon and the nitrogen. And a better way to actually think about this entire resonance form is a delocalization of electron density from the oxygen to the carbon through to the nitrogen. Now at first you may not have predicted this. So for instance, if we look at this nitrogen right here, and if we think about the steric number, so it's making 1, 2, 3 sigma bonds plus a lone pair of electrons, we might think the steric number is in fact 4. And therefore this nitrogen looks like it should be sp3 hybridized and tetrahedral in structure. Well, in fact, the nitrogen is actually sp2 hybridized. It's important for us to understand that the steric number on this nitrogen is actually only 3, not 4, and that this lone pair of electrons should not be included as part of the steric number. Why? Because these electrons are delocalized. And so both the nitrogen written here and the nitrogen written over here should be understood to be sp2 hybridized. It's not possible in a single resonance form for one particular atom to have different level of hybridization. It will adopt, in a sense, the lowest number. So this nitrogen is sp2 hybridized no matter how you look at it. In the same way, this oxygen here, same oxygen over here, this oxygen is also sp2 hybridized. The electrons that we write right here are delocalized in a p orbital. So there's a p orbital about this nitrogen, about the carbon, and about the oxygen. And this is what I'm trying to reflect over here. So we'll do some examples about this in a little bit later in the video. But there's one last point that I'd like to highlight. Be careful. Sometimes we'll see a lone pair of electrons such as the one next to the nitrogen here. Now this nitrogen is indeed sp2 hybridized, but it's already making a pi bond between this nitrogen and the carbon. These electrons are not delocalized. These electrons are what we would say is being localized, and therefore there isn't actually a second resonance form here. You should not draw the second resonance form, and so I'm just going to draw an X through here. The bottom line is when an atom possesses both a pi bond and a lone pair, they will both not participate in resonance. So it's not to say that the electrons are not delocalized in this pi bond. There is a p orbital, there's a p orbital, and in fact there's a degree of delocalization throughout the ring. But these electrons here are found in sp2 hybrid orbitals and they are localized. To make this point a little bit more clear, we say that the nitrogen is sp2 hybridized and the electrons are in sp2 hybrid orbitals, not in p orbitals. So we're referring to these electrons when we make that statement. Now a little bit of practice. So in the key question number 2, we have the example of a histamine molecule. Now this is an interesting molecule in that it has 3 distinct nitrogens and they all have lone pairs of electrons. So your goal is to decide whether or not the electrons are localized or delocalized. Before we look at the answers, I just want to remind you that this particular activity has a series of exercises that follow. And it might be helpful for you to try those exercises and then look at the answers that are posted in Moodle. Okay, so to start with, you may want to fill in the histamine molecule the 3 different lone pairs. And then stop the video and decide whether or not the electrons are localized or delocalized. Use this information to determine the hybridization of each of the nitrogens, and in turn what the geometry is about each of the nitrogens. And just to highlight what I mean by that is, coming back to this example right here, remember in deciding that this nitrogen is sp2 hybridized, we now understand that this nitrogen is not tetrahedral, but rather is trigonal planar. And again, it's represented right here. This nitrogen is trigonal planar. So please stop the video and attempt this exercise. Okay, so now let's look at each of these nitrogens and the lone pair of electrons and decide what's going on. So first of all, the nitrogen found right here. These electrons are delocalized. This is what we would consider an allelic lone pair. We can draw a resonance form where there'd be a new pi bond right here and a negative charge over on this carbon. This would put a positive charge on this nitrogen. We would say, therefore, that the nitrogen is sp2 hybridized, and both the electronic and the molecular geometries would be trigonal planar. In our second example, we'll focus on this nitrogen. We would say the electrons are localized in this case. Note this is an example of where the nitrogen is already sp2 hybridized. It's already making a pi bond. So this lone pair of electrons is indeed localized. We would also say the nitrogen is sp2 hybridized, and both the electronic and the molecular geometries are trigonal planar. So both this nitrogen and this nitrogen is trigonal planar, but for different reasons. Finally, the nitrogen on the end here, these electrons are localized. So there's no further resonance form that you can draw using this lone pair of electrons. The electrons are localized in an sp3 hybrid orbital. The nitrogen itself is sp3 hybridized and has an electronic geometry of tetrahedral. As we would say, the steric number about this nitrogen is 4. And of course, its molecular geometry is trigonal pyramidal. I hope that you have found these set of videos on mastering resonance has helped you review the concept, be able to identify or recognize patterns of when you'd expect to see resonance, and finally understanding what is the implication of knowing that a pair of electrons are delocalized with respect to the hybridization and the geometry of the atom in question.